Everyone. Uh, I am continuing the session with the probable equivalence. Last series we have seen the implication and soundness and completeness of propositional logic. Now I am going to tell about probable equivalence. Probable equivalence of propositional logic implies the two condition formulas, that is pi and psi, which denotes the uppercase and lowercase of an proportion, which must be provably equivalent for the condition if and if only the sequence pi and psi are valid. There is a proof for psi from pi. Another one is going other way around. As we have seen earlier, the psi and pi are provably equivalent to psi and pi. We could just have a well defined sequence which denotes pi implies psi as well as psi implies pi, which is a valid formula. It is also defined as a well defined formula which define the same concept. The examples of probable equivalent formulas are the following, which denotes that the negation of a formula P conjunction Q, negation Q, disjunction negation P, disjunction of P, disjunction Q, and disjunction negation of Q, conjunction negation of P. Similar to that, these the following formulas must have equivalence to each other while following the natural reduction method. The next one is propositional logic as a formal language. As propositional logic as a formal language, we use more complex logical formulas. We mainly focus on trying to understand the precise mechanics of natural reduction rules. It should have a clear rules. What we should stated must be valid for any formulas that should match each patterns required for respective rules. For example, the proof of rule implies E. That is E represents elimination. P implies Q is the first premises. The second one implies P is a premises, and Q from the step 1 to second, Q must be eliminated, which is equivalent to the substitute of P. Similar to that, we have to prove P disjunction negation R, which must be equivalent to premises P. Then P disjunction negation R, which is a premises. Here R implies P, where we will eliminate P, which is similarly equivalent to P implies Q. This is why we express such rules which stands as a generic formulas. Yet these are the precise notation of any formula. Because this text contains various logics, we will see which forms are well formed formulas. We can see a step-by-step process of a formula in the upcoming sessions. Here we can recall the formulas for a propositional logic. Here a provable equivalence, conjunction, disjunction, implication, premises of each formulas, soundness and completeness of propositional logic, derived rules, conjunction, natural direction, declarative sentence. These are the following methods used to form a well-formed formulas. In the upcoming sessions, we can see in detail of other methods of a propositional logic. Propositional logic we simply define as a well defined formula with a valid proof, uh, with a meaningful formation of sequence of sentence, uh, which build more complex logical formulas with the natural direction rules. uh, yeah, we can see the upcoming sessions on the next video lecture. Thank you.